Hi everyone, this time we are going to complete our trig derivatives with the last two trig functions, secant and cosecant. So I'll set up my function f of theta equals the secant sec theta. Now we know from our definition that this is 1 over cosine theta, and I'll be thinking of this as cosine theta to the power of minus 1. If I really want to, I could write this as u to the power minus 1, where u equals cosine theta. Now, applying the chain rule, the derivative f dash theta, it would be negative 1 multiplied by u, and reduce the power to negative 2, multiplied by u dashed, and the derivative, let's just write that, the derivative of cosine is negative sine theta, so multiplied by negative sine theta. What does this look like? Negative 1 by negative sine theta is sine theta, divided by u squared. U was cosine squared theta. So I'll write that as 1 over cosine theta by sine theta over cosine theta, and I think that's best as 1 over cosine is secant, and sine over cosine is tan. That's the derivative. When I start with a function equals secant theta, the derivative is secant theta times tan theta. Let's do the next one. If I start with a function which is cosec theta, remembering my reciprocal ratios, this is 1 over sine theta. I'll think of this as sine theta to the power negative 1, and I could express that as u to the power minus 1, where u equals the sine of theta. U dashed then is cosine theta. Applying the chain rule, f dash theta, so it'll be negative 1 multiplied by u to the power negative 2, and then multiplied by u dashed, which is cosine theta. And this will be negative cosine theta over, and remember u was sine theta, so it's sine squared theta. I think I'll write this as negative 1 over sine theta multiplied by cosine theta over sine theta. Now, 1 over sine was cosec, so that's negative cosec theta, and cosine over sine is cot, and that is the derivative when we started with a function of cosec. The derivative of cosec is negative cosec multiplied by cot. So that's another fairly short little video there for us to complete our series on the derivative of the trig functions.